STING is a interesting grid-based approach. Maybe I'll talk about STING. I think there's enough time to talk about STING. It's a statistical information grid approach. It was initially designed for spatial data mining. So the idea is if you have a map, and on the map you have lots of houses and different regions that you have queries such like this to answer. Find regions of interest. Select the maximal regions that have listed this 100 houses per unit area and a whole bunch of other statistical summary information that you want to fulfill. And you could also, the method can also be used to compute properties of certain region. If we, so it's not a general purpose clustering algorithm, but the idea is interesting. This idea, I say, is not very new. It's again to divide the data into layers and the smaller sections. So let's see, this is one geographic area, like a neighborhood. Then we divide it into smaller. So every small areas can be divided into 4 smaller squares. So it is square, okay? So, and then we compute the information of each square. On this square, how many houses are there? What's their price? What other properties that we care are stored in this cell. And this upper cell going to store the summary information of these 4 cells. So at the very top, you will have most general total numbers for everything that belows it. So the idea, I think we covered this. And then the idea when we answer the query, so parameters of the higher level cells can be easily calculated from the parameters of the lower level cells. You take the sum or the min max and all that. And when we answer a spatial data query, we go with a top-down approach. So start from a pre-selected layer, typically with a small number of the cells. And then we compute the relevance, look at the data saved within each cell and see whether the average match what we want or relevant information is there. And we evaluate the relevance of each cell to the query on hand and find the cell that has the most relevance, and we go down to lower level cells of the relevant cell. So the relevant cell of the final layer have enough statistic information to answer the query. If not, then we can dive into the raw data in the database if needed. So here are some of the answers of the regional queries. Give us the regions that cover, that has property with the average price of this much, things like that. And we can see the expected result. This is a gold standard. And this is what the algorithm returns. We can see right away because that we divide the area into rectangular, square shapes that our final results end up to have straight angles, which does not match the original precisely, but quite close. I attached the original paper here if you wanted to read this. So we mentioned the cluster boundaries are either horizontal or vertical. It only works in low dimensional space, like geographic data exploration. Quality of the results obviously depends on the granularity of the final level, how much you summarized the information and how much information was lost.